Hi, my name is Ajinkya, and this is my demonstration of the program upgrade and migration system I built in Rust, Anchor, Solana, and PostgreSQL as part of the Quant Developer assignment for GoQuant. I'll walk through the architecture, the on-chain program, the backend, and then show a full life upgrade cycle, starting from proposal, approvals, time lock, execution, migration, and rollback. So the architecture consists of the following. So this is the Anchor program. These are the test cases that I've conducted. This is the documentation that I've did during the execution of the project. This is the database and this is the backend. So the Anchor program. This is the Anchor program which handles on-chain logic for proposing upgrades, approving them via Multisig, enforcing a 48-hour time lock, executing upgrades, canceling and migrating account versions. The Rust backend mirrors on-chain state off-chain, tracks proposals, approvals, and migrations, and offers REST APIs plus WebSocket live events. The PostgreSQL database stores audit trail, which consists of proposals, approvals. So these are the proposals, approvals table, migrations, and rollback. So the workflow goes as follows: the upload buffer, then the propose upgrade, then the multisig approves, time lock, execution, migration, verification, and rollback if necessary. This design ensures controlled upgrades, safety, and auditability, similar to how real quant and trading systems enforce safe deployment workflows. So, talking about the Anchor program, I will explain this code. So, this is basically the DTOs which declare the ID, and this is the migration DTOs, rollback DTOs. Then this is the code to connect to the PostgreSQL database. These are the handlers which confirm whether the connection is secured. Then the main code goes as follows. The propose upgrade function which stores metadata, sets time lock, and emits an event. The list proposals list all the proposals that we upgrade. Then the get proposal status, the approve upgrade function which consists of multisig mapping and threshold switching to time lock active. Insert approvals, count approvals, then the upgrade function, execute upgrade function, which checks the authority, checks time lock, and writes pending upgrade plus marks executed. The cancel upgrade function, then the start migration, which sets the version and marks migrated. Sorry, this is the migration progress function. Then this is the create rollback function, which creates a rollback whenever necessary, and the WebSocket events, which handle the socket and status after approval, the helper functions, and the test cases. So this is how the code is. With this, so this covers the full on-chain upgrade state machine. Then I'll start the backend by using cargo run command. So basically, the cargo run command starts the backend, which is running on this port, which is 8080. Then I will also show how to connect to the database. So this is the command to connect to the PostgreSQL database. And this is select now command tells me what the time is so that I know that the database is active. Then we can use the sudo postgres psql command to update any queries if possible, if needed. Okay. So the backend runs on port 8080 and exposes REST plus WebSocket endpoints. Then I will test the health. So if I go to this port and type /health, I will get the status as OK. Now I will show you the upgrade flow demonstration. So the curl command proposes creates the proposal off chain and mirrors what the on chain program will execute after time lock. So this generates an ID. So basically this is the ID which was generated. This is the proposal ID. Now this command actually did not execute because of some syntax error. So this was the command. So these are the approval commands in which once the third approval gets is received, the status becomes time lock active. And I will show the time lock. So basically this is the status command which shows the status of the proposal. This is the ID. This is the status as time lock active and what time it was proposed at and time lock until. Now I will use the execute command. So the time lock period has not yet expired, so it can be executed. So it has been it is started executing. The proposal ID, the accounts, the 123 that we received as approvals earlier. Then the migration. So first I'll show the execution. Yeah. So this is the migration. The curl command in migration simulates a batch migration service that rewrites account states to match the new program version. And I'll show the rollback scenario. This marks the proposal as rolled back and logs the rollback into the audit table, the mirroring real recovery flows. Now that my rollback has been executed, it will be reflected in the database. So when I select star from rollbacks table, I will get the ID, the proposal ID, the reason for the rollback, and when it was created. So this is the entire demonstration of the system. And this completes the demonstration. The system implements full upgrade governance, time lock enforcement, state migration, rollback, backend services, PostgreSQL audit logging, and documentation. So you will find all this in the docs folder inside the GitHub repository that I will be sharing. And so this is it. Thank you for reviewing my submission. I hope I get selected for the quant internship role at GoQuant. I'm really excited for this role and I'm hoping I get an interview. Thank you so much.